Hi everyone, this is lesson 2 and today we're going to look at contact and non-contact forces. Today we're going to try and understand what both of them are and we should be able to describe the differences between them. So if you look at your knowledge organizer, these are the questions that you will be able to answer today. We should be able to explain what contact force is and what a non-contact force is and what the difference is between them. We're also going to be able to list some examples of contact and non-contact forces that you might come across around your house. We're also going to look at gravity, whether it's a contact or non-contact force, and we should be able to explain if it's the same on the moon. So let's remind ourselves, what is a force? So a force can be a push or a pull. You cannot see a force, but you can often see what it does. And if you remember last lesson, we looked at the example of two people playing tug of war. We could not see the force that they were applying to the rope, but we could see the result of the force. So what then is a contact and a non-contact force? A contact force is when the objects are physically touching. So for example, we have friction, air resistance, tension, and normal contact. And we'll look at what each of them are. Then if we look at a non-contact force, that is when the objects are physically separated. For example, gravitational, electrostatic, and magnetic. So have a minute to look at what these definitions are before we take a pause to answer the questions. So pause the video and without having to turn back, try and explain in your own words what a contact force is and what a non-contact force is. Can you tell the difference between them? Then try and list some examples of contact and non-contact forces that you may come across around the house. Okay, so just a reminder, our contact forces are when the objects are physically touching. So for example, if you look at the first picture, in picture A, the man is coming down the ski slope and you can see that he is going at a very fast speed. This is because there is very little friction between his skis and the snow. In the second picture, he is not going down as fast because there is friction between his feet and the grass on the hill. If we look at non-contact forces, this is when the objects are physically separated. So for example, gravity. We cannot see gravity, yet things fall downwards towards the core of the earth. Another example is our magnets. We know that if we hold two magnets close together, if we put the North Pole and the North Pole facing each other, they will repel and push each other away, even though we cannot see the physical force. Some examples that you might have come up with are the opening and closing of the door, lifting a glass, fork or knife, closing or opening a curtain, getting dressed. They're all contact forces. We have to hold the door to open or close it. We have to hold the glass, fork or knife. We also have to hold the curtains if we want to open or close them. And getting dressed, we have to physically touch our clothes to put them on. If we look at non-contact forces, we could say that the books staying on the bookshelf is because gravity is holding them down on the bookshelf. The fridge door has a magnet in it, which is our magnetic force. And if you notice, sometimes when you brush your hair, it may get static electricity. This is also a non-contact force. So let's look at one example in more detail. So if we look at the car, we can see a load of different arrows. We know from last lesson that these size and the direction of the arrow tells us the size and the direction of the force. So if we look at the first arrow, the green arrow pointing downwards, that is weight. That tells us how much gravitational force is pulling the car down towards the earth. Our second force is the blue arrows, which are reaction force. This is a force which the ground is pushing up against the car. We have three more forces. So the first one was non-contact and the second one was contact. The ground touches the wheels of the car. If we look at the final three, take a second to decide if you think they are contact or non-contact forces. So if we look at the big yellow arrow, that is the driving force. That is the force that pushes the car forward. So that is what the amount of force it will take to move the car forward. You can see that there are two small red arrows on the wheels. This is the friction. So this is the force that is going against the car that will stop it from moving. And it's the force between the wheels and the ground. If you look at the purple arrow, this is air resistance. This is the amount of force that the air will push against the car as it is moving forward. The car will not move if the yellow force is not bigger than the purple and red forces together. So some more examples that you could have come up with. So we've talked about these last week, but if we look at whether they're contact or non-contact. So the first one, we have to physically push and hold the box in order to move it. So that is a contact force. Our second one, again, we have to hold the rope in order to pull the box, again, a contact force. We can see the two men are pulling the rope, again, contact force. When we get to the table, you will see that we have labeled gravitational force. That is because we cannot see the force. It is a non-contact force of gravity that is holding the box on the table. There are also a few more examples. Take a minute to try and decide yourself if they are contact or non-contact. Okay, pause the video. Which is gravity? Is it a contact or a non-contact force? What even is gravity? Is gravity the same on the moon? Explain your answer. Okay, so gravity is a non-contact force. We cannot see it. It does not physically touch us in order to pull us down to the ground. It is different on the moon and on all the other planets. If we look at the first image, that shows you the newtons. So last week we said that we measure forces in newtons. So we can see that the gravitational force on the Earth is 10 newtons. If we were to go to the moon, it is much smaller. It is only 1.7 newtons. Now you might have seen pictures before of someone walking on the moon, and they tend to look a lot lighter and jumping, and that is because the gravitational force that is pulling them down is not as strong as the gravitational force that pulls us down on Earth. If you look at the second picture, you will see that the man standing on Earth, he has a mass of 100 kg. It is very important that you understand the difference between mass and weight. In science, when we talk about mass, we talk about how heavy something is, and we measure that in kg. So you might have heard of that before. You might say sometimes that you're weighing yourself, but actually we are finding out what our mass is, as we're using the unit kilograms. In order to find out what we weigh, we actually need to multiply our mass by the gravitational force of the planet. So for example, the astronaut standing on the Earth has a mass of 100 kg. If we multiply that by the 10 newtons, we can see his weight is 980 newtons. Whereas if we put that same man with the same mass of 100 kg on the moon and multiply his mass by the 1.7 newtons that the gravitational force is on the moon, we see he only weighs 162.2 newtons. Don't worry too much, as we will be looking at this in more detail later on. So lastly, try out this experiment. Take 2 sheets of paper, scrunch one up into a ball and leave the other one flat. Now drop both from a height at the exact same time. Which one falls faster? Why do you think that happens? Try this with a number of different shaped objects, and what are you starting to notice? I'd love to hear your answers and I look forward to you sending them in to me. You should now be able to understand what a contact and non-contact force is, and you should be able to describe the difference between them.